Assalamualaikum, dear students. Today our topic is hydrogen chloride or we can say hydrochloric acid. We will discuss its preparation, properties and uses. First, we will take the preparation. Hydrogen chloride is prepared in the laboratory. It is prepared by heating a mixture of sodium chloride and concentrated H2SO4. This rapidly form NaHSO4 plus HCl. This NaHSO4 again reacts with the sodium chloride which is present here. It forms Na2SO4 and HCl. So, how we prepare this in the laboratory? We are taking a round bottled flask. It is a round bottled flask. And it contains sodium chloride and then phenol. Sulfuric acid is added. It is then allowed to pass through a U-tube . And it is collected in the gauge jar . Now, how it is prepared in the laboratory? We take a round bottle flask. In the round bottle flask, we take sodium chloride and sulfuric acid added. The two react, they first form NaHSO4 and HCl. This NaHSO4, sodium bisulfate, again reacts with the sodium chloride present and forms HCl gas. This HCl gas is allowed to pass through a U-tube where we have calcium chloride and it absorbs the moisture and is collected in the gas jar by it is called upward displacement. Upward displacement of air. So, what do we mean by the upward displacement of the air? ये HCl गैस जो है इस हेवियर देन एयर, इस गैस जार का माउथ जो है वो ऊपर की तरफ है, तो एयर जो है वो लाइटर देन HCl है, तो एयर बाहर निकलता है एंड नीचे से कलेक्ट होता है HCl गैस. So we prepare HCl gas by this method, by this technique in the laboratory. Now, manufacture of HCl. How we manufacture HCl or how we prepare HCl on the large scale? Manufacture of HCl gas और हाइड्रोजन क्लोराइड. तो इसके लिए हम सिंथेसिस करते हैं. बाय सिंथेसिस hydrogen and chlorine readily they react in presence of the diffused light or at high temperature and they form HCl. So hydrogen gas plus chlorine diffused light in presence of the sunlight or at high temperature it forms HCl gas. And this is the simple technique by which we allow hydrogen chlorine to react in presence of the light, or in the industry a known volume of the hydrogen and chlorine is allowed to pass in a combustion chamber. While hydrogen is burnt in atmosphere of chlorine. The two then combine and form HCl. This HCl gas is then absorbed in the water and we form dilute HCl. This HCl gas formed by taking the hydrogen and by burning hydrogen in an atmosphere of the chlorine in the combustion chamber, वहाँ पर जो HCl बनता है वो हम absorb that we allow to get absorbed in the water and we get dilute HCl. तो डाइल्यूट HCl को हम मोर एंड मोर HCl गैस पास करते हैं so that this dilute HCl becomes concentrated. So this is how on large scale in the industry we prepare this HCl. These were the preparations of the hydrogen fluoride base, or then how we prepare hydrofluoric acid by absorbing the HCl gas in the water. The properties first physical. तो फिजिकल प्रॉपर्टी में HCl gas is colorless, having pungent smell, and acidic taste. It is heavier than air. It's readily soluble in water. It can be liquefied. Boiling point has a boiling point of 158 Kelvin, sorry, melting point, and boiling point at 159 Kelvin and 189 Kelvin. These were some of the properties, physical properties of this hydrogen chloride or hydrochloric acid, we can say. Now, chemical properties. Chemical properties. Chemical properties. Number one, acidic nature. Dry hydrogen chloride is neutral appearance. But when dissolved in the water, when absorbed in water, it is acidic in nature and turns bilirubinous. Rare. तो अगर हम HCl गैस लेंगे और इसको अलाउ करेंगे, then we in the gas we put bilirubinous paper that gets remains unaffected. लेकिन जब हम इसको डिजॉल्व करते हैं वाटर में और फिर bilirubinous paper उसमें डालते हैं, that becomes red. That means it is acidic in nature, and in aqueous solution it decomposes to form hydronium ion. So HCl plus water forms H3O plus Cl93. So we can say that HCl is acidic in nature, or when HCl is dissolved in water, it is it forms an acidic solution. Second property, with carbonates and bicarbonates, it decomposes carbonates and bicarbonates to liberate CO2. So HCl in aqueous solution, when we take Na2CO3, it forms NaCl plus H2O plus CO2. So we take twice NaCl plus H2O plus carbon dioxide is liberated. Similarly, if we take the bicarbonate HCl aqueous solution, NaH ये सॉलिड है, ये एक्वस है, NaHCO3 sodium bicarbonate. With sodium bicarbonate, it forms NaCl plus H2O plus carbon dioxide is liberated. So with both carbonates and bicarbonates, it liberates carbon dioxide. Number third, with metals. With metals, it liberates hydrogen. Zinc plus HCl aqueous gives ZnCl2 zinc chloride plus H2. Similarly, if we take magnesium plus HCl, it forms MgCl2 plus H2. Aqueous means we are dissolving HCl gas in water and form the aqueous solution of the HCl. So twice बैलेंस करने के लिए जिंक क्लोराइड ZnCl2 दो हाइड्रोजन in the form of gas is liberated. Similarly, magnesium, it is in the solid form. When it is taken in HCl, hydrochloric acid, reacts with the magnesium, it forms magnesium chloride plus hydrogen gas. Now, next property is with metal oxides and hydroxides. Number 4, with metal oxides and hydroxides. It reacts with the basic oxides as well as the hydroxides. For example, we take zinc oxide, this is the metal oxide, and HCl in the aqueous solution, it forms ZnCl2 plus H2O. That means with the metal oxides or hydroxides, chlorides are formed. oxide plus HCl gives ZnCl2 plus water, zinc chloride. Or if we take this is metal oxide, that means it is metal oxides are also called, these are basic oxides. Or if we take base like NaOH, sodium hydroxide plus HCl, it forms NaCl plus H2O. This is again aqueous form. Sodium chloride plus water. That means when hydrogen chloride reacts with the basic oxides or metal hydroxides, basic oxide, zinc oxide, for example, zinc oxide plus HCl, the chlorides are formed. In the first reaction, when the zinc oxide reacts with the HCl, we form zinc chloride plus water, and in the second reaction, when this HCl reacts with the NaOH, it forms sodium chloride and the water. Now next is the oxidizing agent. It reacts with the strong oxidizing agents and it forms to form the chlorine with the strong oxidizing agent like KMnO4 or manganese extra. Chlorine is liberated. For example, KMnO4, potassium permanganate, is a strong oxidizing agent. It is strong oxidizing agent. Like KMnO4, manganese dioxide extra, chlorine is liberated. KMnO4 plus HCl forms KCl plus MnCl2 plus H2O plus Cl2. Now we will balance the reaction. We will take twice KCl. Mn is twice MnCl2. Oxygen is 8 times, 2 4s are 8. We will take this 8 times. Now, hydrogen is 8 and 2 16 times. We will take this 16 times. And now we will balance the Cl. Here, we have 16 Cl, 2 Cl, 2 and 2, 4 Cl, 4 and 2, 4, 6 Cl. We have 16 Cl and we will take this is Cl2, this is 5 times Cl2, then it becomes 16 Cl. Or with MnO2, manganese dioxide, it is also a strong oxidizing agent. It reacts with the HCl, it forms MnCl2 plus H2O or nascent oxygen. We will show this reaction in two parts, like MnCl2 plus H2O, nascent oxygen. This nascent oxygen reacts with oxygen, it forms H2O plus Cl2, and so the overall reaction will be this left hand side. We will add the two half reactions. nascent oxygen जितना भी ब्रेक हो गया उतना कंज्यूम हो गया HCl के साथ वाटर को HCl बनाया. Now the overall reaction is MnO2 plus twice 4 times HCl forms MnCl2 plus twice water plus Cl2. So with the oxidizing agent HCl liberates chlorine Cl2. So in both the reactions we have shown that chlorine gets liberated when the HCl reacts with these strong oxidizing agents. And next property is formation of aqua regia. Formation of aqua regia. HCl, concentrated sulfuric acid, combines with the concentrated nitric acid in the ratio of 3:1. That means we are taking 3 parts of HCl and 1 part of nitric acid, and they form a mixture that is called aqua regia. This aqua regia even dissolves the noble metals like platinum, like gold, due to the action of nascent chlorine on these metals. Now we will take the reaction HCl plus HNO3. Both are concentrated. When they react in the ratio of 3:1, they form NOCl. NOCl. Plus, you see hydrogen 3 H2O. So 4 times plus what is liberated here? Hydrogen is 3 and 1, 4 times is 2 times plus Cl. Again we will balance it. 3 hydrogen plus 1 hydrogen, 2 to 4 hydrogen. 3 Cl, 1 Cl, 2 Cl. Nitrogen 1, oxygen 3, oxygen 1 and oxygen 2, 3 times. This nitrous chloride, water and nascent chloride or nascent chlorine. This nascent chlorine then it attacks platinum or gold 4 times, it forms PtCl4. It is the nascent Cl, liberation of the nascent Cl which attaches these noble metals which otherwise are unreactive with the HCl, that is unaffected by the HCl or the nitric acid. So platinum with the nascent chlorine, it forms platinum tetrachloride or Au plus Cl thrice, it forms AuCl3 unique chloride. So these are the reactions with when the aqua regia react with these noble metals. Swab uses. This hydrochloric acid or hydrogen chloride in otherwise is used for, it is an important acid used in the laboratory. It is used for the industrially important chloride compounds. And this HCl is also used for the preparation of aqua regia. It is used for the cleaning of the metal surfaces. It is used for the preparation of the aqua regia, which then affects or dissolves the noble metals like the gold, like the platinum, and it is used in the manufacture of chlorine. also used for the extraction of glue from wounds. And these are some of the properties of uses of HCl. Now, this will do today. I think you have understood the preparation properties and uses of some of the uses